Hello and welcome to Math with Martinez. We are in our Algebra 2, Unit 4, looking at expressions, factoring, and equations with rational exponents. And in this Part 2 video, we are looking at determining the linear factors and quadratic factors of a polynomial expression by factoring specifically the sum and difference of two cubes. So let's go ahead and get started there. What we're really looking at is recognizing special patterns that can assist you in factoring many polynomials. If we can recognize the pattern, then we'll be able to factor our sum of cubes and our difference of cubes. And so to get started, I would love for us to go ahead and begin by listing the first 10 perfect cubes. You need to know your perfect cubes to be able to recognize that, oh, this is potentially a sum or a difference of cubes. And so the perfect cubes are just the result of taking your integers and cubing them. So what is 1 cubed? What is 2 cubed? What is 3 cubed? What is 4 to the third power? And so on and so forth. Those perfect cubes are, of course, 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. 6 to that third power, when we cube it, that means taking 6 and multiplying it by itself 2 more times, is 216. 7 cubed is 343. 8 cubed is 512. 9 cubed is 729, and of course 10 times 10 times 10 is 1,000. We need to see these numbers and immediately recognize, oh, that's a special number. That's a cube. Because if we are factoring a polynomial that specifically is a binomial, if it looks like this, if you have something cubed and then adding something cubed to it, if your two terms are both cubes and you're adding, then the pattern is as follows. You're going to have two polynomials. The first is going to be a binomial, and it's going to be your A and add to it your B. And that A and B are going to be the square roots of your A cubed and your B cubed from the original binomial. Then you would have another, but it's going to be a trinomial. It's going to be your A value squared. Then you're going to subtract the product of A and B, and then add to it your B value squared. And then this would be the fully factored result. These are the factors of your sum of cubes. So let me show you all with an example. We're going to use two colors. I'm going to use red and blue here to kind of highlight it. And I'm actually going to come back up here and highlight my A, so we can keep that color coding going. Okay, so we're looking at this binomial, and I'm noticing here that 8 is one of my perfect cubes, and 27 is one of my perfect cubes, and the operation between is adding. So this is a sum of cubes. So we're going to want to find the cube root of each of our term. So we're going to want to write this as your A value. Let me get my black. There we go. I'm going to expand this out. So we're going to write it as A, and then plus our B value. And then we're going to take our A and square it, and then subtract from that the product of A and B, and then lastly add our b value and square it. So we're going to write it in that format by finding the cube root of each of our terms. So we're going to take our first term. We're going to find our a value by taking our first term and taking the cube root of it. What's the cube root of 8? In other words, what cubed is 8? It's 2. And what cubed gives you x cubed? Just x. Similarly, we're going to do so for our b. To find b, we're going to take the cube root of our second term. What number cubed is 27? That's 3. So now we have our a and b values, and we're ready to go ahead and apply our pattern. That is to go ahead and put it into the binomial and trinomial, substituting the specific a and b values that we found, beginning with a, which was 2x. Then we're going to add to that our b value, which is 3. In the next, we need to take all of a. I need to take all of a, which is 2x, and square that entire term. Then subtract my a value, which is 2x, and multiply that with the b, which is 3. Lastly, add to it our b value, which is 3, and that should be squared. Now all that remains is for us to go ahead and simplify this. What will we have? We will have, of course, that first binomial stays exactly the same. No simplification is needed there. But when you take 2x and square that, that means, remember, to square something means to multiply it by itself. So that's actually 4x squared. So be aware of simplifying correctly there. It would be 4x squared. Then minus the 2x times 3 is going to result in 6x. And then plus 9. That is our sum of cubes fully factored. And like it, there is another special factoring pattern that exists when instead you have a difference of cubes, when you're subtracting. When you're subtracting, it's going to look almost the same. You're going to have a binomial and then a trinomial. You're going to find, oops, I'm sorry, let me back up a little bit here. If originally you had your binomial, then your binomial being your a value, sorry, not squared, I'm so used to squared, your a value cubed, but then now in between we're no longer adding, we are subtracting from that another perfect cube, then it's going to be of the form a and then minus your b, and then in that trinomial you're going to have your a squared, and then you're going to add to that the product of a and b, and then lastly add to that your b squared. So the pattern is almost the same, but the signs are a little bit different when you are adding or subtracting your cubes. So be aware of that. So we're going to go ahead and rewrite this so that it's in this kind of format. So we're going to rewrite it just like this. And to do so, we're going to need to identify what our a and our b value are. So to find your a, you're going to want to take the cube root of your first term. So what cubed is x cubed? Just x. Similarly, find your b value by asking yourself, well, what cubed is 64? Don't worry about the sign being negative there, just the b, the thing that is being subtracted. What cubed is 64? Be very careful. Some of us are going to want to say 8, but that is what happens when you square. But the cube root of 64 is actually 4. All right, so now we're good there. What we need to do is go ahead and substitute our a and b into the pattern. You're going to have subtraction here, and then it's going to be addition between the terms in your trinomial. So our a value is x, our b value is 4. Take your a value and square it. That's nice because it's just x squared. And then you're going to be multiplying x and 4. And then you're going to have your 4, and that's going to be squared. You might be able to skip all the way down and do that simplifying in your head, but I like to show it here slowly for us when we're doing this the first time. So there's the binomial. It's going to be x squared. The proper way to format this would be to write it as 4x and then 16. There you guys go. An example where we were looking at simplifying, factoring a difference of squares and a difference of cubes and a sum of cubes. A great ability to be able to recognize patterns will make factoring so much easier. If not, then you would probably be really stuck if you didn't recognize, oh yeah, this problem right here is a sum of cubes. This is a difference of cubes. We've got to be able to recognize that this is that pattern and that this is the factored result when you're able to factor that down further. So if you guys had any questions, please take a moment and share those now. And until next time, stay fired up.